Let's talk about the squeeze theorem. Suppose we're looking for the limit as x approaches 4 for some function, but we're limited in our knowledge. All we know is that f is between g of x, which is equal to 1. The function is just 1, and h, which is 5. Let's just stop right here and get a visual. Can we find the limit? And if so, what is it? Well, 1, 2, 3, 4, 5. And we're going to do a lot of color coding on this particular lesson just so we don't have things run into each other and look alike. But this function, which will be green, is the function that is g. This one's g, and this one will also be green. This one's going to be h. So h is equal to 5, g is equal to 1. Those are the two functions. And I want to know what happens at 1, 2, 3, 4, limit as x approaches 4 for f. And all I know is that f is between g and h, not alphabetically. So I'm switching colors. I'm going to go to blue for a second, and we're going to put the f function. I'm just making something up, and it's totally okay. Here goes f. It's in between them. Okay, so there's the f function, and I want to know what the y value is that I'm approaching as my x value approaches 4 for my f function. So as I do that, I'm doing this, and I don't know, because I had to guess what this thing looked like. So we're looking for that, but all we know is that can we find the limit? And no, we cannot. It took a big, long explanation to do so. So let's try it again. Same question, but it's a little different criteria here. Suppose we're looking for the limit as x approaches 4 for f, but all we know is that f is between g of x, which is 2.8, and g of x, which should say h of x. I will make that correction on yours. H, which is equal to 3.2. And can we find the limit? And if so, what is it? Let's draw another picture. We're going to have 1, 2, 3, 4, 5. I drew a little bit too much. Let's go green on G, which is at 2.8. 2.8 is about right here. There we go. So here's G. And here's H is at 3.2. 3.2. Oops, I was about to put the number. That should be G. This should be H. There we go. Get it right. And I know that F is between them. And I know you're looking at this saying, oh, well, it's narrower. I can narrow it down a little more. But there's still an infinite number of numbers in between these two horizontal lines. So if I was to draw F, just any old which way I wanted to, but I'm restricting it in between. I can make it a straight line. I can make it wiggly, do whatever. But in the end, 1, 2, 3, 4, I still don't know the exact y value. I know it's somewhere between 2.8 and 3.2, but I don't know exactly what it is. Similarly, I knew that the f function and or the limit as I approached 4 would be somewhere in between 1 and 5, but I don't know what it is. Okay, let's try this again one more time. All right. Suppose we're looking for the limit as x approaches 4 for f of x, but all we know is that f of x is between this function and that function. Can we find the limit, and if so, what is it? And I'm going to draw this one as well, and don't think, oh no, I have to draw that, and don't panic. 1, 2, 3, 4, and then we're just going to go from there. I drew it a little sideways. So let me grab my calculator, 1/2 x minus 4 squared. Now we know how to graph this without a calculator. I truly hope we do. Let's brighten things up just a little bit here. There we go. And this is a parabola facing upward, open a little more open because of the 1/2. Shift to the right 4, up 3. I know that, you know that, but let's just, nope. Let's go to a standard window, zoom 6. And when we do that, we're just going to get a visual for it. And there it is. And I'm asking about what happens at 4 for the f function. So I feel like that's going to be relevant. So I'm going to go to the graph, the table. And let's see what happens as we get to 4. I know the answer. This is going to be 3, by the way. 4 is 3. An x value of 4 gives me a y value of 3 on the g function. So let's do that. 1, 2, 3. And so my g function, which will be green, just to be consistent with what I've done so far, is there. And this guy right here, that's the g function. Let's graph the h function. And the h function is going to look like this. It's negative sine of, oops, too many parentheses, x minus 4. I think it'd still work though. And then plus 3. We're going to graph that in the same place, on the same coordinate plane. There it is. Oh, you see what happened here? Do you see what happened here? Do you see what happened at 4? You get a 3 on the g function. You get a 3 on the h function. So if I was to graph the h function, which I'm about to do on my paper, I would have this thing that just kind of goes back and forth, and I might not have the right number of humps in there, and it's not spaced exactly right, but I have this kind of idea, and this is h. All right. Thanks for hanging with me so far. The waves should be like evenly spaced, and mine are not. But the main idea is what is about to happen right here, because f is between them. So I can draw f any old which way I want. I can draw f any old which way I want as long as I'm between them, as long as I'm between them, as long as I'm between them. So we can do all kinds of crazy stuff here, but when I get to this, it channels it through at that one point. There we go. You can draw all kinds of crazy stuff, but at that point you are restricted, and that is the point, literally. I am looking for the limit as x approaches 4 on the f function. Do I know it? Yes, I do, because f is between, or equal in this case, between f and g, and so therefore the limit as x approaches 4 of f of x is equal to this actual value, which was 3. Okay, here we go. A few things that are important to note, I'm going to highlight them. This is a theorem that is kind of common sense. If f is less than or equal to g, which is less than or equal to h. Okay, in the examples we've done so far, f was between the other two. And in this case, g is between the other two. In this case, they're in alphabetical order. I don't care what letters you use. It really doesn't matter. The letters are arbitrary. What's important is that you have a function that is stuck between two other ones for all the x's in an open interval except maybe at c. This interval contains some value. In this case, it was 4. And it is there except for possibly at c itself, because we don't know exactly what happens at the point where we're trying to find the limit. Maybe the function doesn't exist. Maybe there's an open circle and a dot somewhere else. But all the rest of the function is going to be stuck in between them, or on that interval. And if the limit of, let's look at the letters here, and this is important as well. I'm going to go ahead and highlight it. If the limit of the lower function, lower, why is it lower? F is less than g, which is less than h. If the limit of the lower function equals the limit of the upper function, which is equal to some value of L, then, all right, here's the rest of it. The limit as x approaches c for my g function is also equal to L. All right, what am I talking about? Let's draw one more picture. Here is a function. Draw it however you want, but f is less than or equal to g, which is less than or equal to h, and the highest one, h, the lowest one, f, have the same limit at some c value. So there's a c value here, and we're going to stick with green being the upper and lower, well, it'll be f and h in this case, not g and h. Again, letters are arbitrary. So you can draw it however you want. Draw it any old which way you choose, as long as they have the same limit, which is L. And now we're going to have another function that's in the middle. By the way, this function, the lower one, was f. This upper one was h. And there's some other function that is stuck in the middle. Stuck in the middle with you. It's stuck. It's an old song. It's stuck. Boom, right there. So this function, the one in the middle, stuck between f and g, f and h, is g, and its limit is equal to L, because it's crammed in between the other two. So let's go back up at the very top of the page and talk about the little secondary title or secondary comment. This inside of a sandwich is stuck between the slices of bread. When you make a sandwich, you don't do bread, and then something in the middle, and you just kind of hold your bread like this. You smash them together. So the stuff in there is smashed, okay? This is not a sandwich. This is not a sandwich. This is a sandwich at that one point at least. This is a sandwich at that one point.